Hello, my name is Emerson, and today we're going to be looking at the Halocode by Makeblock. The Halocode is a small Wi-Fi capable microcontroller that's able to be programmed using both block-based programming languages that are similar to Scratch, as well as Python. But before we get into programming it, let's take a look at what these can do before we even take it out of its box. On the bottom, they have a slot with a micro USB port exposed. And after plugging it in, you can see the Halocode come to life. The first thing that you should see after plugging it in is a little LED show, demonstrating all of the colors and patterns that are possible to make. After taking the Halocode out of its box, we can better see all the sensors that the Halocode has to offer. The most obvious thing being the 12 LEDs that surround the board. They are all individually addressable RGB LEDs. Closer to the center, we also have a button. Besides that, we have a speaker, which is capable of detecting audio from your environment as well as speech. There's also an accelerometer on the board to detect motion as well as direction. On the edge of the board, we have 4 pads that are capable of detecting touch and can be interacted with through programming. And on the back, I think we have the coolest thing about this board. On the back, we have a Wi-Fi module, which allows us to connect to the internet and have all sort of added functionality. Going back to the front of the board, we can see a few more of the pre-programmed functions. If I click the center button, it'll switch to a mode which demonstrates the ability of the touchpads. So if I touch any of these borders, it creates a sort of ripple effect going through the lights on the board. If I switch it again, it'll now go to a mode that detects volume. So the louder I talk, the louder the lights will go. If you click the button again, it'll switch to a mode using the accelerometer. And when you rotate the board around, it'll light up the LED that's facing farthest down. Finally, if we click the button one more time, it'll bring us to our last pre-programmed function, which honestly, I'm not too sure what it does. From what I can tell, when you shake the board, the lights bounce back and forth a random number of times before stopping on one of the 2 edges. Clicking the button again will bring us back to the light show. Alright, so now let's move into the programming of the Halocode. So, on the Makeblock website, you can go to Download and select the version that's appropriate for you. They have downloadable versions for Windows and Mac, as well as iOS and Android apps. They also have something called M-Link for Linux, Chromebook, as well as Windows and Mac that lets you program through the browser. I'm going to be using that, and to access that, you can go to ide.mblock.cc. And you can see that the layout is very similar to Scratch. You have your stage, you have your blocks, you have your programming area, you have your sprites, you have your backgrounds. But something new is actually this Devices tab. So in this tab, you can add different Makeblock devices. In our case, the Halocode. So I'll go ahead and click Add and select the Halocode from all the list of devices. So now I have the Halocode in our project. I have it plugged in through USB, so I'll go ahead and connect to it. Select it from the drop-down, click Connect, and now we're connected. There are 2 different modes that we can put the Halocode in. There's the live mode, and there's also the upload mode. The difference being live mode is meant to be interacted with, plugged into a computer through USB, and allows you to interact with the sprites, similar to maybe how you would interact using your keyboard or mouse in Scratch. The upload mode is a little bit different. It's kind of a plug and forget kind of thing. You plug it into any sort of power, maybe a wall adapter, maybe a power bank, and it starts up and will execute code. Maybe it checks the weather, checks different sensors, and then sends the data through Wi-Fi. It doesn't interact with the sprites like the live mode does. And you can see when I switch back and forth, in upload mode, I don't have the ability for when the green flag is clicked or when the space key is pressed. Whereas when I switch to live mode, I don't have the option for when Halocode starts up. So live mode is very cool because it lets you actually interact with these sprites, whereas upload mode, you kind of upload the code to it, and then when it starts up, or maybe when a button is pressed, different things will happen. They're very similar, but there are tiny differences. All right, so I made this example program. In the Halo code, I have it programmed that forever it'll set this move variable to the angle that the Halo code is currently tilted at. In the sprite, this panda sprite, I had variable is set to and detect if it's ever touching one of these blocks to stop. And in the blocks, I pretty much just have it spawn a new one every 0.7 seconds. So this program will use the gyroscope from the Halo code to have this panda sprite move back and forth. And you can see in the corner here, I have it actually printing out the current angle that the gyroscope is tilted at. Have it move however many steps that variable is set to, and detect if it's ever touching one of these blocks to stop. And in the blocks, I pretty much just have it spawn a new one every 0.7 seconds. So this program will use the gyroscope from the Halo code to have this panda sprite move back and forth. And you can see in the corner here, I have it actually printing out the current angle that the gyroscope is tilted at. So first I need to actually connect the Halo code. So going to the Devices tab, selecting the Halo code and clicking Connect. Selecting the USB, click Connect. And so now we're connected. And now when I hit the green flag, when I tilt the Halo code left and right, you see it moves the panda left and right. And the goal is to just avoid these blocks. You can also see the move variable updating in the left corner based on how I tilt the Halo code. Something else that Makeblocks provide is some example programs. So up in the corner, you can go to Tutorials, Example Programs. And the one I want to look at is this LAN broadcast. So this uses 2 or more Halo codes to interact with each other. The way they do it is something that Halo code calls LAN, which is pretty much using Wi-Fi but without actually connecting to a Wi-Fi hotspot. So they interact with each other wirelessly without actually needing to connect to the internet. So this one has 2 Halo codes in it. In the first one, when the Halo code starts up, it'll create a LAN called Mesh1, and when its button is pressed, it'll broadcast this light message on the LAN. The second Halo code, when it starts up, it joins that LAN, and when it receives the light message, it'll light up the LEDs green, wait 1 second, and then turn off. So this is an example of where you want to use the upload method. Because we're not interacting with the stage or any sprites at all, and when we want this Halo code starts up, we do need to use the upload feature. So I'll go ahead and connect the Halo codes. Connect, select the first Halo code, connect and upload. Go ahead and disconnect from that one, connect to the second Halo code, and upload. So now with the program uploaded on both Halo codes, when I click the center button on the first one, it lights up green on the second one. So it is doing this wirelessly. They are connected to USB to the computer, but it isn't communicating through that. So you could, in theory, hook this up to a power bank or any wall adapter, and it will still wirelessly communicate from one to the other using the Wi-Fi, but without actually connecting to a hotspot. The final thing that I want to demonstrate is this reflex test game that I created. So on one Halocode, I actually created this in Python. In the second one, I just did it with the blocks because it is simple enough. So, starting with the second one, when it starts up, it'll join this LAN named mesh1, and when the button is pressed, it'll broadcast this stop message on the LAN. The second one might be a little more complicated to read, but when it starts, it'll show all red. It'll show all red, and it'll start the group mesh1. And then forever, it'll turn all the LEDs off, wait a random amount of time, show a sort of green color, reset the timer, sleep for 1 second, and then repeat all that. When it receives this stop message, it'll get the timer and print out how long it took. So it's sort of a reflex game. So I'll go ahead and connect to the first one and upload the code. Disconnect, go ahead and connect to the second one, upload the code, and then I'll go ahead and actually reconnect back to the first one because we're going to be using the console to read the output. So I'll go ahead and connect, upload one more time. So now the main Halocode will randomly flash green. There we go. So when I see it flash green, I will push the button on the second Halocode. And in the little console at the bottom of the Makeblock software, it will print out how long it took me to actually press that button. So it's sort of a little reflex game. Again, using this LAN functionality, you can expand this to multiple Halocodes, not just two. Makeblock does supply you with ton more examples to show off the different functionality that you can do with the Halocode, and they're all available on the MBlock IDE, either available for download or in the browser.